Go.
I'm Camille.
I'm Jennifer. This is our lab. So that's potassium chloride and barium nitrate. No precipitate. Sodium nitrate and barium nitrate. Still no precipitate for the second time. Barium nitrate with sodium carbonate. Hard to see with the glare, but it's white and cloudy. So this is barium nitrate and barium chloride. No precipitate. This is barium chloride and potassium chloride. No precipitate. This is barium chloride and sodium nitrate. No precipitate. This is barium chloride and sodium carbonate. It's white and cloudy, so there is precipitate. Sodium carbonate and potassium chloride. No precipitate. Sodium carbonate and sodium nitrate. No precipitate. Sodium nitrate and potassium chloride. No precipitate. It's clear. Okay, so for set 1, we only had 2 reactions that formed precipitates. The first reaction was barium nitrate reacts with sodium carbonate to yield barium carbonate and sodium nitrate. And we know that sodium nitrate is soluble for 2 reasons. One is all cations, which are ions with a positive charge, are soluble with the nitrate anion. And also, if you look at the sheet, all of these top solutions are soluble. So NaNO3 is right over there. So we can also look at the sheet and say that it is soluble, and that leaves barium carbonate as the precipitate. And before I show you the net ionic equation, I will explain to you the difference between molecular ionic and net ionic equations. A molecular equation is a balanced chemical equation in which ionic compounds are written as neutral formulas rather than ions. So this right here is a molecular equation. An ionic equation shows all the soluble ionic species broken into their respective ions. So what that means is, instead of writing them as compounds, they're going to be written as individual ions with charges. And the key word here is soluble, meaning that everything but the precipitate can be broken down into ions. So an example of an ionic equation would be this right here. So it's broken up into its ions. So this is from the first reaction that we discussed. So as you can see, everything is broken up into their respective ions except for the precipitate barium carbonate. And you're probably wondering why I have crosses through some of the ions. Well, that brings us to our last type of equation, which is net ionic. And a net ionic equation is an ionic equation with all the spectator ions removed. And what spectator ions are, they are ions that don't take part in the reaction actively. So they show up on both the product and the reactant side, and they cancel each other out. So if we go back to the previous example, nitrate and nitrate canceled out, and sodium and sodium canceled out, and that brought us to the net ionic equation of reaction number 1, which is barium ion and carbonate ion yield barium carbonate. So this is sodium sulfate and barium nitrate, and there is a precipitate. It's like white and cloudy. Sodium sulfate and barium chloride, and there is precipitate. It is white and cloudy. Sodium sulfate with strontium nitrate, and there is a precipitate. It is white and looks like milk. Sodium sulfate and aluminum sulfate, and there's no precipitate this time. This is aluminum sulfate and barium nitrate, and there is a precipitate. It looks white and clear and milky. So this is aluminum sulfate and barium chloride, and there is precipitate. It looks white, clear, and milky. So this is aluminum sulfate with strontium nitrate, and there is a precipitate. It's white and cloudy. Strontium nitrate and barium nitrate, and there is no precipitate. It's strontium nitrate with barium chloride, no precipitate. It is clear. Okay, so this is our last one. This is barium chloride and barium nitrate. It is clear, so no precipitate. This is reaction number 2 that formed a precipitate from set 2. We have sodium sulfate reacts with barium chloride to form sodium chloride and barium sulfate. How do we figure out the precipitate for this one? Well, we're going to do a little cross-referencing. I took a reaction from set 1, so we're going to be looking at this reaction right here and right here. So second reaction was barium chloride and sodium nitrate yield sodium chloride and barium nitrate. So how do we figure this out? Well, the top reaction formed a precipitate, whereas the bottom one didn't. So when a reaction doesn't form a precipitate, we know that both of the products are soluble, so I'm just going to put an S for soluble. So we know that sodium chloride and barium nitrate are soluble, and if you look at the top reaction, there's also a sodium chloride, so we know that that's soluble, leaving barium sulfate as the precipitate, and that is our second distinct precipitate. And the net ionic equation is barium ion and sulfate ion yield barium sulfate.
So what is a precipitate? A precipitate is a solid which forms in a reaction involving aqueous reactants. How does a precipitate form? When a solution cannot dissolve any more substance, the solution becomes saturated. Adding more of the substance would cause a precipitate to form.
And just expanding on what Camille said, how does it form? Okay, well here I have a simple double replacement reaction, AB plus CD yield AD plus CB, where both A, B, and CD are soluble. In the AB solution, there are A plus and B minus ions, and in the CD solution, there are C plus and D minus ions. When the two nonmetal ions, B and D, switch to form the products, all of these ions are in one solution. So let's say that CB is insoluble, represented by the color difference of blue and red. It will then form a solid, also known as the precipitate. In a saturated solution, the rate of dissolving is equal to the rate of crystallization. Because they are the same rate, the solvent cannot dissolve the solute any further, resulting in a precipitate.